Earth is a dynamic system. Powerful natural events such as earthquakes, volcanic eruption, mudslides, tsunamis, tropical cyclones, and blizzards are inevitable because they are products of the workings of nature. These powerful events become parts of our daily lives and are viewed as hazards in our lives. Stories about dramatic events and the risks associated with these natural disasters paved the way for long-chain campaigns on how the risks associated with them can be minimized and further destructions can be prevented. Are these powerful natural phenomena viewed as plain natural hazards? What is the importance of these natural events in our lives? If we look around, we should see that our environment, the surface of the earth as a whole, has been shaped and fashioned by these powerful natural events. This module will discuss about earthquakes and the forces that generate them, not only as hazardous events, but also as natural events that help fashion and shape our environment.
Among the many processes in the lithosphere, the most terrifying are earthquakes. They strike with a suddenness that no one is prepared for. Small tremors or vibrations may pass without alarming people, but major earthquakes can lead to the loss of many lives and cause severe damage to property. The Philippines is located along a convergent plate boundary where plates collide. This means that we will be experiencing earthquakes. To be able to prepare for their occurrence and minimize their effects on us and our property, we must understand a number of things about earthquakes. First, what exactly are earthquakes and how are they generated? Please watch this video lesson.
The Philippines is located along the Pacific Ring of Fire. How does this affect us? People who live along the Ring of Fire have to put up with earthquakes and volcanic eruptions. As I have mentioned earlier, in this video lesson, we will focus on earthquakes. Earthquakes are considered as the most frightening things that anyone can ever experience. You grew up believing that the earth is rock solid and steady, but then the ground suddenly shakes and you do not know what to believe anymore. Strong earthquakes have caused countless deaths all over the world, even before people have started recording these events. No wonder scientists have been working very hard to find a way to predict when an earthquake occurs. No one can stop quakes from happening, but there are things that people can do to avoid or reduce loss of life and damage to property. The first step is to have a clear understanding of the occurrence of earthquakes. An earthquake is a sudden shaking of the ground caused by the underground rock masses that suddenly shift in position. As the term implies, it is a sudden shaking. In Filipino, we call it biglaan. Therefore, there is no warning. Unlike typhoons, we can hear from the news about the public storm warning signals, wherein we can prepare ourselves on what to do. Whereas in terms of earthquake, since it is a sudden shaking of the ground, they cannot tell us the exact place, the exact time when an earthquake will strike. Earthquakes are associated with faults. But what is a fault? Okay, this activity, entitled A Faulty Setup, will help you understand what is a fault. You can do this very simple activity on your home. So the objective of this activity is to describe the appearance of a fault. Here are the materials that you need. 2 sheets of cardboard or folder. Used folder will do. Fine sand, ruler, and newspaper. First step, spread the newspaper on the table. You will do the activity on the newspaper. Number 2, arrange the 2 sheets of cardboard edge to edge. So just like what is shown on the screen. Number 3, pour sand along the boundary of the 2 sheets. Just like what is shown on the screen. Next, with the ruler, flatten the top of the sand and make 2 parallel lines. Now, move the sheets slowly in the direction shown in the figure. Move it slowly. And first question, as you move the sheets, what is formed in the sand? Number 2, what happens to the lines? The lines that is being asked on the question is 2 parallel lines. As you move the sheets on the opposite sides, what happens to these parallel lines? So here are pictures that will give you a clue. Okay, let's answer. Number 1, as you move the sheets, what is formed in the sand? Okay, a crack, a line or break is formed in the sand. What happens to the lines? So the parallel lines are shifted or displaced. Now let me show you this picture. Can you compare what you see in the picture and what you saw in the activity? So I have here a sample of the appearance of your setup on your activity. Is there something in the picture that looks like what was formed in the activity? Do you see anything similar? If you look at the picture carefully, you can guess that the road was originally in one place, but the road is no longer continuous. There is a cut across the road, and now there are 2 sections. One section has moved with respect to the other. Based on the activity in the picture, you can probably guess what a fault is by now. When we say fault, it is a break in the Earth's crust, and along the break, significant movement has taken place. A fault is a fracture or zone of fractures between 2 blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep. So again, when we say fault, it is a break or crack in the Earth's crust, and along that break, there is a significant movement. And that significant movement is what we call as the earthquake. An earthquake is caused by a sudden slip on a fault, much like what happens when you snap your fingers. Before the snap, you push your fingers together and sideways. Because you are pushing them together, friction keeps them from moving to the side. When you push sideways hard enough to overcome this friction, your fingers move suddenly, releasing energy in the form of sound waves that set the air vibrating and travel from your hand to your ear where you hear the snap, just like this one. The same process goes on in an earthquake. Stresses in the Earth's outer layer push the sides of the fault together. The friction across the surface of the fault holds the rocks together so they do not slip immediately when pushed sideways. Eventually, enough stress builds up and the rock slips suddenly, releasing energy in waves that travel through the rock to cause the shaking that we feel during an earthquake. Layers of rocks may experience several types of stress. Remember that the rocks that we are talking about here is not the piece of rock that we can get on the ground, but here we are talking about the layers of rocks deep within the earth. The stress is a force that acts on rocks to change its shape or volume. It can be a type of stress that is pushing towards each other, pulling, or it could be the type of force that slides past each other, or when rock slides past each other. The first type of stress is what we call as the tension force, or the pull apart stress. The tension force is a type of stress that pulls on the crust, stretching the rock from opposite directions. That's why it is called pull apart stress. So the arrow shows that tensional forces deep within the earth is pulling the rocks away from each other. Rocks under tension lengthen or break apart. Alright? Tension is the major type of stress at divergent plate boundaries. One of the topics that you will learn in grade 10. Next is compression, from the word compress. So I think you have now an idea that it is the opposite of tension. If tension pulls apart, compression is a force that squeezes rocks until they fold or break. In compression, it squeezes the rocks together, causing rocks to fold or fracture, or it can cause breaks. Compression is the most common stress at convergent plate boundaries. In converging boundaries, plate moves towards each other. Just like what I have mentioned a while ago, you will learn this type of plate boundaries in grade 10 science. And for the last type of stress, we call it shearing. Shearing is a force that pushes masses of rock in different directions. When forces are parallel but moving in opposite directions. Shear stress is the most common stress at transform plate boundaries. The forces inside the earth result to faults. So the forces that was mentioned a while ago, again, we have tensional, compressional, and shear stress or forces. Because of these forces deep within the earth, it results to faults or breaks on the layers of rocks. These forces also produce the kinds of fault experienced when movement of rocks occurs. So that means to say, the type of fault movement depends on the type of stress that is experienced by the layers of rocks. Rocks along a fault move up and down, side to side, or in a combination of directions. At this point, let us discuss the types of faults. So again, when we say faults, these are cracks on the layers of rocks, which are brought about by the stresses experienced by rocks deep within the earth. We have the tensional, as rocks pull apart, compressional, when they are squeezed, and shear, when they slide past or move in opposite directions. The first type of fault is what we call as the dip slip fault. When we say dip slip, it has vertical movement. When we say vertical movement, it can be upward or downward. Dip slip fault has two types. The most common type of a dip slip fault is the downward movement, and we call it as the normal dip slip fault. Whereas if the fault moves upward, we call it as the reverse dip slip fault. So again, dip slip fault have vertical movement. For downward movement, we call it normal dip slip fault. For upward movement, we have the reverse dip slip fault. If we have vertical movement, we also have horizontal movement. We call it as the strike slip fault. Generally, we have the two types of strike slip fault. The first type is sideways movement to the right. Since it moved to the right, we will call it as the right lateral strike slip fault. I know that you have now an idea on the second type of the strike slip fault. If the first type is the right lateral strike slip fault, wherein it moves sideways to the right, we have left lateral strike slip fault, sideways movement to the left. So there you go, the two major types of faults, dip slip and strike slip. So it was mentioned earlier that the type of fault depends on the type of stress that is experienced by the layers of rocks. Let us go into details. Normal faults are common or are formed when the crust is stretched or pulled apart by forces in opposing directions. So meaning to say, normal faults occurs along diverging boundaries. When the plate boundaries move away from each other, it experiences tensional forces or pull apart stress that causes downward movement of faults. And since fault moves downward, we called it as normal faults. Whereas reverse faults are formed when the crust is squeezed or compressed. We call it as compression towards each other. So if normal faults occurs along diverging boundaries, reverse faults occurs along convergent boundaries. And lastly, strike slip faults are formed by shearing forces due to the movement of the two plates against each other and the release of build-up strain. So therefore, we can say that strike slip faults occurs along transform boundaries. But remember that strike slip faults can be left lateral or right lateral. So suppose there are two blocks of rock separated by the fault plane. Imagine yourself standing on one of the blocks and facing the trace of the fault. Observe the block on the other side and note the direction of its movement. If it moved to your right, the fault is classified as a right lateral strike slip fault, meaning sideways movement to the right. If the other block moved to your left, then the fault is a left lateral strike slip fault. Out in the field, the direction of movement is determined by observing features on the ground that were displaced by the fault. An example of a left lateral strike slip fault is the Philippine fault. In reality, the Philippine fault consists of several faults parallel to one another, and among geologists, it is called the Philippine Fault Zone. The fault extends from Luzon through the eastern part of Visayas down to eastern Mindanao. Whereas an example of a right lateral strike slip fault is the famous San Andreas Fault in California, USA. It consists of different fault segments and is more accurately referred to as the San Andreas Fault System. So again, an example of a left lateral strike slip fault is the Philippine Fault System, while an example of a right lateral strike slip fault is the San Andreas Fault System. Now let us try this activity. Get a flexible ruler that is 12 inches long. 2. Hold the ruler horizontally at both ends. 3. Bend the ruler. Do you feel the ends of the ruler pushing against your hands? That push is energy. It is stored as the ruler bends. 4. Now, release the ruler. The ruler straightens out. We say that the ruler is elastic since it goes back to its original shape. Now, hold the end of the ruler firmly with your right hand and bend the ruler again with your left. Energy is again stored in the bent ruler. While keeping a tight grip with your hand, take away the left hand quickly. So let us watch this simple demonstration. So again, for these steps, you have to hold the ruler on your right and bend it on your left, then take away the left hand quickly. So let us watch this video. The ruler is bent, then release. Observe what is happening to the ruler. Okay, what happens? The ruler vibrates as it snaps back to its original position. The stored energy is released. In the same way as the ruler in the previous activity, energy that is stored in rocks are compressed or pulled apart may be released when rocks snap suddenly. The energy is released in the form of vibrations. We call these vibrations earthquakes. So again, an earthquake is a vibration of the earth due to the rapid release of energy. The process whereby rocks bend, store, and suddenly release energy is described in the elastic rebound theory, which was proposed by Harry F. Reid of Johns Hopkins University as a mechanism for the generation of earthquakes. He came up with the idea after the occurrence of the terrible San Francisco earthquake in California, USA in 1906. So the elastic rebound theory is an explanation for how energy is released during an earthquake. As the Earth's crust deforms, the rocks which span the opposing sides of a fault are subjected to shear stress. Slowly, they deform until their internal rigidity is exceeded. So at this point, Since you have now an understanding of what an earthquake is, why it occurs, and the types of faults, let us check your understanding. Question number 1. Which of the following statements is not true about earthquakes? A. An earthquake is the sudden shaking of the ground. B. Earthquakes can be caused by normal or reverse fault. C. Earthquakes cause a lot of destruction anywhere it occurs. And letter D. The time and location of earthquakes can be predicted. Time's up. For number 1, the answer is letter D. The time and location of earthquake can be predicted. That is not true. It is because earthquake is considered as one of the most frightening types of natural disasters because it happens on the suddenness of the day. It just happens without a warning. Unlike any other types of calamity such as typhoon. Number 2. Which type of fault is a result of tensional force? So again, when we say tensional force or stress, when rocks are pulling away or moving away from each other. A. Normal dip slip. B. Reverse dip slip. C. Left lateral strike slip. D. Right lateral strike slip. Alright, the answer for number 2 is normal dip slip fault. Normal dip slip fault occurs along diverging boundaries wherein rocks or layers of rocks are subjected to tensional forces or tensional stress. Number 3. What kind of stress does the image below show? A. Tension stress. B. Shear stress. C. Compressional stress. D. Frictional stress. Okay, the answer is letter B. Shear stress. Number 4. Which of the following is not type of earthquake fault? A. Reverse. B. Normal. C. Compressional. D. Strike slip. Time's up. The answer for number 4 is compressional. Compressional is a type of stress that causes strike slip fault. And number 5, earthquakes are common occurrence in Japan, Indonesia, and Philippines. Why is this so? A. Japan, Indonesia, and Philippines are considered archipelagic countries. B. Japan, Indonesia, and Philippines are found within the Pacific Ring of Fire. C. Japan, Indonesia, and Philippines are located near the equator. D. Japan, Indonesia, and Philippines are surrounded by seas. Okay. The answer for number 5 is, alright, letter B. Japan, Indonesia, and Philippines are found within the Pacific Ring of Fire. Watch out for the next video lesson. It is time to get to know the meaning of terms used when earthquakes are reported in the news. See you again next time. Thank you.